talked about what it was to be side, 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 and side angle, side congruent. What did you need to be able to prove to use side, side, side congruency? 3 congruent pairs of sides. What about side angle, side congruency? What kind of angle? Yep, the angle needs to be congruent, but where did the angle specifically need to be? In the middle. It has to be an included angle. Remember, for side angle side, it has to be an angle that's included between our congruent sides. There's no such thing as angle side side. It's a bad angle. It doesn't exist. That's the donkey. Donkey. We have a different one for that. It's called hypotenuse leg, but it's only in a right triangle.
I mean, I didn't do that.
All right, so for this first section, we're going to state whether or not our triangles can be proven congruent with side, 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 or side angle side. If yes, we're going to write our congruency statement. No, you just say not congruent and we're done. Y'all ready? All right, so number 1. We've got, I'm going to stick with what we were doing yesterday with the highlighting. So we've got Q is congruent, QY and KC. We've got YT and KP. And then angle K is congruent to angle Y.
Hey, Mr.
What up?
I'm going to interrupt, but on the homework last night,
Yep.
it would be wrong if it was like CK, not KC.
Yep.
On the test or whatever.
Yep.
Are you going to take off?
Test multiple choice. But yes, if you do not align your vertices correctly, it would be incorrect. At least half.
What is that?
29th or 30th. One other day y'all are. Y'all got a quiz next week over this stuff. Why not? Well, then it's on 29th. Look at that. Total fam. Okay. So, do we have enough information to say that these are congruent? Either side, 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 or side angle side. So first off, we've got QY is congruent to CK. Oh, Calvin Klein. We've got angle Y is congruent to angle K. And we've got TY is congruent to PK. So we've got 3 pieces. We need 3, right? So we need at least 3. Is our congruent angle, because we've got a side, and an angle, is our congruent angle included between our congruent sides? Is Y and is K where our 2 sides, congruent sides, come together? Yes. So that means, yes, it is congruent by side angle side. And then now let's write our congruency statement. Like I said, generally we're going to go in alphabetical order for the first one. So how would you say triangle on the left in alphabetical order? That's reverse alphabetical order. I like it though. Q, T, Y. Okay. Like I said, generally it's in alphabetical order, so it's not a bad practice to be in. And then the second one, we just need to line up our vertices. So if we went Q, Y, T, what are we going to go? Well, who do we know is in the middle? We know K is at least in the middle because it has to be congruent to T. Or wait, K is at least last because it has to be congruent to T. I'm looking at theirs. There's a difference. So they went, go ahead, I'm listening.
Oh, never mind.
CPK, yep. Bueno. CPK. All right, let's look at number 2. What do we have is congruent? So somebody tell me some congruent pieces. What? AB is congruent to CD, yeah. All right, that's 1. We need 3. What else we got? AD is congruent to BC. All right, we got 2. Where's the third one? Because that's, so we've got 2 sides so far. What do you mean in the middle? It's a shared side, so AC is congruent to AC. AD, either way. We went, yeah. And that's also a side. So have we shown congruence? I guess we can go back and highlight a little bit, right? So we've got our yellow, AB and CD. We've got our green, AD and BC. And we've got our blue, which is that shared side. Do we have enough information to prove congruence? Yes. Based on which postulate? Side, side, side. Our theorem, sorry. Okay. So what would our congruent statement be? So triangle A, B, C is congruent to who? So we need to make sure we just match up our pieces. So if we started at A and went along the double line, C, D, A. Yep.
So it's not alphabetical?
The second one might not be alphabetical. The second one, we must match up the pieces. That's all that matters. Because what must be true? A must be congruent to C. B is congruent to D. And C is congruent to A. Is there a way of checking it?
Is that kind of a way, like, to double check?
Sure. Yeah, absolutely. Number 3. These are the ones that start to mess with y'all's brains. What do we know? What do we see?
Yeah, I say yes.
But why?
Because I'm following that right now.
Okay, so if it's SAS, what are our congruent pieces? You got to tell me what our congruent pieces are. JM is congruent to who? LK. All right. So that is a side. Go ahead and highlight that, rascal. Hold on one second. So we got JM is congruent to LK. All right. What's our next piece? Angle M is congruent to angle K. All right. I like it. Is that a side or an angle? That's an angle. So green. So this guy right here, M is congruent to K. All right, so that's only 2 pieces. We need one more. One more time. Why? That doesn't work.
So this is
JK is congruent to LM. How come? We don't know that it's a midpoint. You're correct. What did I tell you guys are going to use a lot?
Oh.
What is it? A shared side. Do these guys have a shared side? Which one? Nope, ML and JK aren't. So if I were to take M and K share a side, what do you mean? The bottom side. Is that not present in both triangles? Why not, Bradley? So what if I were to kind of take these triangles and separate them? Oh gosh, that was awful, Sean. Sean, come on, man. You big dummy. So what if I pull those guys apart? Right? So I've pulled them apart, so now I've got J, M, K, and M, K, L. What do we know about MK? They're both the same. It's a shared side. So this bottom base is the third piece we need to prove. They're sneaky. They're super sneaky. So what's our congruent statement for that side? Nope. MK is congruent to MK, and that's a side. So now I got you, brother. Now go ahead and tell me what you're about to say. What's our congruent statement for our triangle? Congruent based on what? Side angle side. Whoops. Side angle side. Let's try to be alphabetical. What do you got? JKM. Just we try to be alphabetical if we can.
It's not required.
Not necessarily required. It's not like a rule, but standard practice. So JKM would be what? LMK.
Do we just leave N out of this, or is it just not?
Yeah, N's not part of it. I bet you N will show up later, though. I'm telling, like, no, but when we get the corresponding parts of congruent triangles are congruent, I bet you N comes into play. But for right now, we're just staying on the basics, yo. Number 4, what do we got?
U.
What about U? So we got to get specifical here, because U could be any of these angles. So we've got to get specific if we're talking about that angle. SV is congruent to TW. Does everybody agree? SVTW? Yeah. All right. So SVTW. What else do we know? Green there. Bang. All right. Which one? Why? So we can't expect anything unless they tell us. We can't assume it. So that's why I was saying earlier, we've got to get specific when we're talking about U. Because it could be that angle, or it could be this angle, or it could be that angle, or it could be the top one. So let's get specific when we talk about U. Let's use that 3-letter description. So let's go S to U to V. So angle S, U, V is congruent to what? T, U, W. Yeah, so we just got to be specific because U could have been any one of those four angles. So we got, there's our blue. What do you mean?
Like the other option.
No. So, are our triangles congruent? On what? Side angle side. What must be true about our angle for it to be side angle side? It's got to be where the two congruent sides come together. Is this angle where our two congruent sides come together? It is not. Is it where the blue or the yellow and the green meet? It ain't not. So this is that ASS angle. This is an angle that does not prove congruence. This is the donkey. Okay, so this is not necessarily congruent. They could be, but we do not have enough information to prove congruence. So not congruent. What's wrong? What's wrong? Yeah. All right, let's look at number 8, and then we'll move on to our proofs. Number 8. What do we know? What is it? Angle A to angle E? How come? Yep, so AC, so segment AC is congruent to segment EC. Yes, that's true. Is that what you were trying to say? Yeah, just remember that when we're using segments, it's a 2-letter. All right, so we've got AC to EC. EC means here in French. Fun fact. DC is congruent to BC. All right, that's also another side. Fantastic. So they both share that C point, so C is the midpoint. You could not say that. Now, so the reason you can't say that is because CD is a single tick and AC is a double tick. What else do we got? Why not? So how many pieces do we need to be able to prove it? 3. We've only got 2. Is there a third given piece? Yes. So vertical angles are always congruent. So this would be a vertical angle pair. It doesn't show it because that is something we can always assume. Vertical angles are always congruent. That's one of our theorems we know. That's one we can use. Angle. So what would that angle be called? We got to get specifical because there's so many different C's. Get specifical. ACB is congruent. Good. And that's an angle. We want to be specifical. What's whack? Oh, yeah. They'd be sneaky on us. So, are our triangles congruent? You don't know? Why not? But why are they? Well, so for SAS, where must our congruent angle be? And between our congruent segments. Are our congruent angles between our congruent segments? They are. So because they are, this is side angle side. So what would our congruent statement be? triangle ABC is congruent to triangle EDC. Bueno. Not too bad, right? Let's do a couple proofs, and then I'll set y'all free to start your homework. Let me fill out these statements for you, because I'm never going to give y'all a proof where you don't have at least the left side filled out. What's that? It's just the more you do them, the more practice you have being able to like understand the flow of things. So as y'all get along, there might be later in the year when you're like, Coach, let me try one of them blank ones. And you'll be like, what? You never know. You may feel like, man, I can do this. Look at it. Your confidence will be overflowing. Oh, Peter. What's wrong? You want to fill in the blank ones? Hey, thunder kick, son. And I've got my Superman shirt on so it can happen. Yes, you. You with the face. Superman, that would be an interesting battle. Superman versus Cap. You think?
No doubt about that at all.
I mean,
My guy has a shield made out of like plutonium. Yeah, exactly.
but he can wield the hammer of Thor.
No, not really.
He wielded it in the last movie.
That's true.
And he was able to summon the lightning, which means he's actually worthy.
Why are you fighting against it? You're just some like jacked up genetic looking.
I mean, technically an alien from a different planet that was sent here by his parents when his planet was destroyed, but you know.
I mean, unless you have kryptonite,
It's true.
make a shield out of kryptonite.
There we go.
That's true. If he did that, then it'd be a variant.
There's a video game that you can do that on. Y'all got them all filled out yet? Number 4, triangle ABD, or angle ABD is congruent to angle CDE. No, that's only when you're going equal to congruent. What? I like that face because it means you're like thinking. I can deal with that face. You can't see it? Is that better? We'll let y'all write it down. I know you're blind. That's okay. Oh, yeah? It's only Thursday. Man, you got back-to-back 4-day weeks. Y'all are so daggum spoiled. Just 4-day weeks galore. And then it's like 3 weeks to a whole week off for Thanksgiving. Yeah, and those are half days.
Yeah, that's fine.
Yeah, half days.
I hope y'all get to practice on Christmas.
Probably will. Not gonna lie to you.
That'd be good.
Because of the playoffs,
Yeah, man.
just trying to stay out. Like go online for the playoffs. Because someone get a game we have to work with.
That's interesting.
You don't know. We're thinking about it.
I hope not. Yes. Y'all ready? All right, here we go. Let's mark up our figure. They told us AB is congruent. to CD. What's wrong? Yep. AB is congruent to CD. Fantastic. Little single tick. What else did they tell us? AB is parallel, so that means remember we put that little arrow. The arrow signifies parallel. All right. What else do we know? D is the midpoint of BE. So if D is the midpoint, so this is D, and it's the midpoint of this segment, what does that tell us? If that's the midpoint, it's what? Congruent. So these two must be congruent to one another. Wow. Look at you guys figuring stuff out, man. I'm so proud of y'all. I tell you what, makes me happier than a June bug in July. Because he made it that long. All right, so let's start working on our proof now. How did we know AB was congruent to CD? Was given. They told us. That's highlighter dummy. Can't write in highlighter dummy. How did we know AB was parallel to CD? They also told us that much. Good thing. Given. How did we know D was the midpoint? Yeah, they told us that one too. Woo, we're on a roll. How did we know ABD is congruent to CDE? So that would be if we were talking about the segments. So let's go. I wish they would have done that first. So let's go ahead and 5 is definition of midpoint, but they were trying to put the angle in the middle to help you guys out. But generally speaking, the flow would be after statement 4, you would make statement 6. 5, thank you. After statement 3, you would make statement 5. All right, so where on earth did they get this whole ABD is congruent to CDE? Where did they get that from? What is it? So this angle is congruent to this angle. How come? But why are they congruent?
Because God made him congruent.
He did do that, but he made it specifically congruent for what?
For us.
So we've got, remember, we've got parallel line, transversal, one in and one out. What do we call that? Corresponding angles. All right, so these are parallel, yes. This is my transversal, yes.
That's transversal.
It is. So this angle is outside the parallel. Why would it could be? Whatever you want, yeah. It's corresponding either way. Oh yeah. Oh yeah, Peter. If you guys see parallel lines in the given, you need to start looking for one of those 5 relationships. And most of the time, it's going to be the congruent relationship, so that knocks it down to 4. 3. Just kidding. Okay, so how did we know congruent? So, yep, so we got a side. We've got a congruent angle and another congruent side. The biggest question, is my congruent angle included in our congruent sides? No? Why not? Is my congruent angles included between my congruent sides? Yes. So yes, we can conclude that these are congruent. And like you guys said, based on side angle side. I love these things. All right, let's do one more, and then y'all can start your homework. And I'm here to help if you get stuck on a proof. Maybe. Hopefully not. All right, so we've got, oh, I need to write in your givens, right? Yeah. Yes. This one's a little easier, yeah. Do this one. So Km is congruent to Nm. Lk is congruent to Ln. Lm is congruent to Lm. And triangle LKM is congruent to triangle LNM. I would hope so. Yes. False. I'm going to guess you can't even hit it 87.
Coach.
Yes.
Coach, you pitched me, I'll hit for it.
Sure. That's why you play lacrosse, not baseball, because you can hit it that far. If you're done, yeah. Y'all ready? Yes. All right, so let's look up our givens. Km is congruent to Nk. I hope so. That's not what I want. All right, good. Boom. Lk and Ln. All right, that's these guys right here. Double tick, double tick. All right, there's no more given information we can use. Everybody agree? Yep, I hope so. That's it. All right. How did we know that Km was congruent to Nm? They told us. How did we know Lk is congruent to Ln? They told us. How do we know Lm is congruent to Lm? It's a shared side. And what do we call that? Very good. That looks like a B. Still looks like a B. Reflective. Hey. Enough of the personal attacks on Coach O. So, yes, now that we know it's congruent, we can drop a triple in there. So what makes our triangles congruent? Side, side, side. So slow. At least it's working better for me today. I don't got to drop kicks through the moon. All right. Y'all can start your homework. If you get stuck, I'm here to help. I guess it's not due till Monday, but y'all can get it done today. Yes. Yo, what? Oh.